Okay, so we are going to continue on with application of trig ratios. Now, I have a couple of word problem examples that I'm going to work through. These are actually on the worksheet from the previous two examples, but if you want to follow along with these to make sure you're on the right track, that is fine. So, let's hop right into it. Question number one. A hiker sets out to climb a mountain with a 4,000-foot vertical ascent as shown in the diagram below. Really, it's to the sides, this diagram right here. If the angle of the incline alpha equals 12 degrees, what is the total distance he has to travel to reach the summit to the nearest whole foot? So, in this example, the angle that we are working with is right here. Okay, you can see that. The angle we're working right here is alpha and has a measure of 12 degrees. Okay, so what we need to do is find the total distance he's traveled to reach the summit. So from the bottom to the top. All right, so just like we talked about in previous examples, we have to identify our opposite, adjacent, and hypotenuse sides, and based on that information, that'll tell us what trig ratio to use. Okay, so like I always do, from my angle, draw my arrow to identify my opposite side. Then the side directly next to the angle is my adjacent side. And then my hypotenuse side never changes. It's always opposite this right angle box, or it's always the longest side of a right triangle. So now it's a matter of determining, well, what trig ratio do I use? Okay? And remember, we have three different trig ratios: sine, cosine, and tangent. Okay, so quick refresher. The sine of x, remember x is just any angle, is opposite over hypotenuse, while cosine of any angle x is adjacent over the hypotenuse, and tangent of any angle x is opposite over adjacent. Okay, so I've been given this angle alpha, and I've been given the opposite side, and I need to find the hypotenuse. So what trig ratio requires the use of the opposite side and the hypotenuse side? Well, that's sine. So I'm going to set my problem up. I'll set it up right here. The sine of my angle 12 is equal to opposite, which is 4,000, over the hypotenuse, which is x. Okay, and that's how I set it up. And I like putting this over 1 so I can set up my cross multiplication. So after that, it's just a matter of cross multiplying and dividing. So I'm going to do x times cross multiplication, the sine of x. So I'm going to write down here, x times the sine of 12 is equal to 4,000 times 1, which is 4,000. Okay? And then, in order to get x by itself, once again, I divide everything by the sine of 12. Okay? Now, before you do this calculation, I always say make sure that your calculator is, here's the mode button, is in degree mode. You want that degree highlighted. Okay? So now I'm going to put this answer in the calculator. So 4,000 divided by the sine of 12. Okay? Close those parentheses. And I got 19,238.93. So x is equal to 19,239. I'm just going to go ahead and round off. And that's answer number C. Letter C. C is not a number. Okay, so that's example number 1 of a little more application. Let's take a look at example number 2. Okay, an airport departs Miami every morning and flies to Boston, and then flies from Boston to Los Angeles, as shown in the diagram below. if the plane takes off from Boston at an angle that's beta equals 60 degrees, and the angle from Boston to Los Angeles is approximately 3,000 miles, what is the distance to the nearest mile between Miami and Boston? So they're creating like a nice little right triangle for us. So here the values aren't explicitly labeled, so we got to do some labeling. So I know my angle beta, see here's alpha, here's beta, so this is the angle that I'm working with, so don't automatically assume it's in this corner. So the angle beta right here is 60 degrees. Okay? And it says, and the distance from Boston to Los Angeles is approximately 3,000 miles. Okay? 3,000 miles. Okay? What is the distance to the nearest mile between Miami and Boston? So they got that X there, so that lets me know I'm trying to find this X. So I need to identify my opposite, adjacent, and hypotenuse sides. So draw my arrow. There's my opposite side. X has my adjacent side. And the distance from Boston to Los Angeles, well, that's my hypotenuse, because it's opposite that right angle box, and it's the longest side of the right triangle. So now, how do I set up to solve? Well, 60 is my angle, and I'm being asked to find the adjacent side when I've been given the hypotenuse. What trig ratio uses adjacent and hypotenuse? Cosine. So to set this up, cosine of 60, there we go, okay, is equal to adjacent, which is x, over the hypotenuse, which is 3,000. Okay? Now, if you know anything about special rights, you can figure out what the cosine of 60 is, but we'll talk about that a little later. So, just like the last example, I cross multiply. Okay? It's a little cross. It's a little jumbled up. But x times 1 is x. Okay? X is equal to 3,000 times the cosine of 60. Okay. So, grab my trusty calculator. Once again, make sure it's in degree mode. So I'm going to do 3,000 times the cosine of 60 and get 1,500. It's almost like the cosine of 60 is 1/2. So, answer for x is equal to 1,500 miles, and the answer there is B. Okay? So, a couple more examples on how to use your trig ratios. Remember to label your opposite and adjacent sides and know what angle that you are working with. Be careful on question number 2 because it gives you an angle here called alpha, but the one you're working with is beta.